Hello, I'm Eric from Bosch Power Tools. Welcome to this short instructional video about the safe use of handheld drilling machines. When using any power tool, the operator is exposed to a number of common risks like noise, hand-arm vibration, dust and flying debris. The control measures necessary to manage these risks are well known and documented, with professional advice available from the HSE, for example. The main focus of this video is to highlight the ever-present risk of injury due to incorrect handling of a handheld drilling machine. Almost every drilling application requires that the drill bit is turned clockwise by the machine. In order to do this, the machine has to produce turning power or twisting force. This is commonly referred to as torque. Generally speaking, as the power, the size, the weight of the machine increases, then so does the torque output. It is a common misconception that should the drill bit, being rotated clockwise, suddenly jam, that the so-called reactive torque from the machine will turn the machine in the same direction, i.e. clockwise. In fact, the reactive torque causes the machine always to kick anti-clockwise around the jammed drill bit. The human hand-arm system is very sophisticated and allows movement of at least 180 degrees without any serious problem or discomfort. Unfortunately, when a drill bit jams, the handle of a typical drilling machine can rotate 360 degrees in just 1/10 of a second, which will almost certainly result in injury to the hand, wrist and arm. The more powerful handheld drilling machines are normally supplied with front handles like this one. It's very important that these front handles are fitted securely and held correctly by the operator, so that should kickback occur, the handle is thrown into and caught by the operator's hand, so that control is maintained. If the handle is in the wrong position and the operator is holding it this way, when kickback occurs, the fingers are thrown open and control is lost of the machine, resulting in injury to the hand and arm. For a left-handed operator, the handle can be repositioned, for example, like this. In this case, the right hand is steadying the machine and once again catching the kickback when the machine turns anti-clockwise. Many handheld drilling machines have safety clutches as standard, and it's a common misconception that the safety clutch will always save the operator in the event of a sudden drill bit jam. This is simply not true. If the front handle is not being held correctly or it's not secure, then the clutch will not operate. It needs a reference to work against so it can disengage the drive and stop the machine from rotating or kicking back anti-clockwise. This machine has a safety clutch, and as we've said before, this will only work if the handle, the front handle, is securely fitted and is in the correct position and held correctly by the operator. So I'm turning the machine through 90 degrees, holding the handle so that it kicks into my hand so I can catch the kickback, and you will hear the safety clutch activating. Let's now take a look at some typical drilling scenarios and see how the operator can best manage the risk of injury from kickback. So here we are, we're about to drill a 38mm hole through this block work wall behind me with a view to installing a pipe through the wall. We're going to do this with a dry diamond drill and a small rotary hammer. And to avoid drilling too high above chest height, which is never a good idea, we're going to be operating from a platform. But before any drilling can take place, we need to do a scan to make sure that we're not going to hit any cables or pipes like this. As you can see, we've got a green light there, no indications of any nasties in the wall, so we can go ahead and drill. Before using any power tool, it's very important to wear the appropriate PPE, like goggles, gloves and ear defenders. In this case, we'll be drilling stone, so we will be using an M-class vacuum cleaner and a dust extraction adapter. We're drilling a small diameter hole through this wall with a view to installing, for example, a gas pipe, and we'll be using this particular position for the front handle, and you can see that the handle will kick into the hand, so I'll be able to catch the kickback, and if a jam should occur, the safety clutch will activate. If you're working close to a ceiling, as you might for a boiler flue or an extractor, then it's permissible to turn the handle through 90 degrees, but maintain that contact with the hand so that the kickback goes into the hand and you can catch the kickback and control the machine. For larger diameter holes, maybe over 100 millimeters, it's worth considering a diamond drilling rig where you have a wall mounted machine, so the possibility of injury through a jam is eliminated. As you saw, we were drilling this hole from a platform. I'm off the platform now, I'm standing on the floor, and in this situation we have a serious risk of injury not only to the hand-arm system but also to my head, because the machine is actually level with my head. This should be avoided at all costs. Just to demonstrate, with the handle down, which is incorrect because the handle will fly out of the hand, so you won't be able to catch the kickback. This machine will rotate, and remember, 360 degrees in only 1/10 of a second. If my head is close to the machine, then the machine will turn and possibly cause a head injury as well. So here we're about to drill a larger diameter hole through this wall with a diamond core. We're using a 2-speed impact drill designed for dry diamond drilling. We selected first gear so that the speed is not too excessive for the diameter of the core, and we're extracting dust via an M-class cleaner suitable for stone through this pickup connection here just behind the diamond core. You'll notice I'm holding the handle vertically so that should kickback occur, we're able to catch the kickback into the hand as usual and activate the clutch inside the machine. So here we're installing some anchors into a concrete floor in a warehouse to fix a barrier. We're going to be drilling downwards this time. When drilling downwards, you need to hold on to the handle in a different way, and that is to brace it against, in this case, your shin if you're a right-hander, or just by using the appropriate hand to catch the kickback if you're a left-hander. Right-handers have it easy in this respect because the handle can track down the leg, down the shin, and maintain that important reference so that should kickback occur, the handle won't move and the clutch will disengage reliably. Okay, so we're using dust control here with an M-class cleaner and a dust extraction adapter. We'll just start the hole without so that I can get a reference point to start with. Here's another common drilling scenario where we're drilling down through a concrete floor with a view to installing pipes or cables. We're using a larger rotary hammer this time, an STS Max hammer. And the front handle position, again, is absolutely imperative to get right if you're to avoid injury. So having the handle like so is incorrect. People will try to work the machine like this, but without any sort of proper reference, the handle will quickly overcome the left hand and the machine will spin, damaging the right hand and arm. So turn the handle into this position to 9 o'clock, if you like, from the operator's perspective, and you've got now the benefit of your left leg as a reference so that when the machine starts to penetrate the material, you can keep your hand and the handle resting on your leg using that as a reference. So should a jam occur, then the clutch will kick in and protect you from any injury. Left-handers would need to adopt a different position for the front handle, something like this, which means that the usual into the hand, catch the kick back position can be used. So in the event of a jam, the operator can maintain control of this front handle and avoid injury. Working, standing away from the machine is not advisable because if the machine flips, it will contact parts of the body, maybe damage a leg or a knee, and this is to be avoided at all costs. Just a tip when drilling through concrete where rebar or reinforcing steel is likely to be encountered, rather than using a standard 2-cutter hammer bit, it's a good idea to use one with 4 cutters. They are less likely to jam and cause kickback, and thereby could be considered safer to use than the 2-cutter bit. They don't drill particularly any faster than a 2-cutter bit, but are less likely to jam when they encounter a rebar. Of course, you can't drill through the rebar with these bits, but in terms of risk of jamming and kickback, they do significantly reduce that risk. Remember, when drilling, always use the front handle, securely fitted and held correctly. Adopt a secure footing with your feet apart and work from a stable surface or platform. Try not to drill from a ladder if it can be avoided. And avoid drilling with the machine close to your head. Stay safe and thanks for watching.